Hello guys, this is Christine again. Today we will get some more help for organic chemistry. Today we're going about we are about to talk about enantiomers. So first let's define what is enantiomers. Enantiomers, they are non-superimposable mirror image. It means that a compound and its mirror image are different. Non-superimposable is mean different. So enantiomers are different from each other. They are non-superimposable mirror image. And the second thing is that enantiomers have the same physical properties because all of their arrangement in space are the same. So they will make the same connection or the same intermolecular connection interaction. That's why they have the same physical property. So physical property here is like boiling point or melting point, or it can be also the solution, stuff like that. Their physical property, they are the same because they have the same connection, they have the same arrangement in space, so those have the same intermolecular interaction leading to the same physical properties. And the third point is that enantiomers are optically active. Optically active here means that they have the ability to rotate the light when they go through that compound enantiomers. However, Racemic mister, this word we see a lot. Racemic misters mean that 50% of one compound and 50% of its enantiomer. These make up a Racemic mister. In this case, they are optically inactive. Why they are optically inactive? Because the enantiomer have the ability to rotate the light to some degree. So if it's rotate the light to some degree, one compound will rotate to about, like for example, an alpha degree. For compound 1, it will rotate the light to alpha degree. But then is enantiomers of compound 1. The enantiomer of compound 1 will rotate the same degree, alpha degree, but now it's different direction. It will be negative direction. One will rotate in positive direction, but its enantiomer rotate in negative direction. So they cancel out and is leading to the optically inactive in Racemic mister. They have the same amount, so they rotate the same amount and they cancel it out, leading to the optically inactive. So how do we draw enantiomers? Drawing enantiomers is really simple. You only have to draw the skeleton of the carbon chain. So draw the carbon skeleton first, and then you will flip whatever dash to wet or wet to dash. Or in another way, we can say that we flip the R chiral center to the S chiral center and vice versa. So let's go through some examples to see how do we draw enantiomers. So for example, if we have this compound and we want to draw it enantiomers. So in enantiomer, I will keep the same skeleton, the carbon skeleton. So I draw the same carbon skeleton in here. So I keep the carbon skeleton the same. But now I flip whatever dash to wedge and whatever wedge to dash. So in here I have a wedge. Now I flip it to a dash. And also I have a dash. Now I will flip it to a wedge. Okay. And from here I have a wedge right here. I flip it to a dash. And a dash, I flip it to a wedge. So this is my enantiomer. These are enantiomer of each other. So we just keep the same skeleton and we flip whatever dash to wet and whatever wet to dash. And also if you check for is R and S configuration, you'll see that this is R, it's flipping between R and S. So let's do one example so you can see it better. So if I do it here, I will have this is 1, and I have this is this will be here. I have this is 2, this is 3, and this is 4. So if I imagine myself in a space, I have 1, 2, 3, 1, 2, 3. This is an R configuration. So if I consider in here, I have this is 1, this is 2, this is 3, and this is 4. And if I imagine myself in here, I have this going 1, 2, 3. It's going counterclockwise. So this is an S configuration. So R flipped to S and S flipped to R. So these are our enantiomers. So for this one, it's the same thing. We will draw the skeleton the same. So keep the skeleton the same. And then you flip whatever dash to wet and whatever dash or wet to dash. So in here we have a wet on OH, and also we have a dash on hydrogen. We don't draw hydrogen here, but it implies that we have a dash on hydrogen. So in here I will draw the skeleton and I flip from wet to dash, and then also from dash to wet. But because hydrogen, we can just ignore it, so we don't have to draw it in here. And in here we have a dash. I draw it as a wedge. And I have a wedge. I draw it as a dash. So these are an enantiomer of each other. So in order to draw an enantiomer, it's really easy. You keep the same carbon skeleton, and then you flip whatever dash to wedge. Or in another way, it means that we're flipping from R chiral center to S chiral center. Okay, and that's it for today. And good luck with you guys for studying organic chemistry. Thank you for watching the video.